So this next talk is the introduction to NIM libp2p. So you have to mirror your screen, I think, or at least, do you have them? Oh, he's saving the last video, so we gotta hold on a second. Great. Me too. I could eat. Okay. Intro to there it is. Are we good? All right. So you are Richard.
Yes.
Ramos. Oh, hi. Finally, nice to meet you. There you go.
All right. Hello, everyone. And today I'll be talking about NIM libp2p. It is a NIM-based implementation of the libp2p protocol stack. We're going to look into how it differs from other implementations, how to build your own protocols with it, and why NIM makes sense for this kind of work. So, who is this guy? Yeah, nice to meet you, everyone. I'm Richard. You can see there my socials, GitHub, my account on the social network formerly known as Twitter, and also Discord. And yeah, I'm the developer lead of the P2P team at VAC, which is part of the IFT, the Institute of Free Technology. You might be wondering what is VAC. VAC is the research and development group within the IFT that helps startups that are also part of the IFT to build strong foundations. We work at low level, building protocols and libraries, and we support projects in different ways. Sometimes we jump in and build the software for these startups, especially when the software that we build can be reused by other teams, and that way everyone benefits. And sometimes we also do applied research, meaning that we test new ideas, write the specifications, and also publish our findings. And this mix of building and researching let us deliver solid, future-proof tools for the IFT and also for the whole ecosystems. And one of the things that we work on is NIM libp2p. So yeah, what is NIM libp2p? Like I mentioned earlier, it is a native ground-up implementation of libp2p written in the NIM language. It is designed for resource-constrained environments like mobile and embedded devices, but also for Ethereum 2 clients, among other projects. And it prioritizes modularity, low-level control, and also a minimal amount of dependencies. Currently, NIM libp2p is used across different projects within the IFT, and I would love this list to grow. And yeah, some of the projects that in which NIM libp2p is currently being used are, for example, Nimbus, an Ethereum 2 consensus client optimized for low resource devices like Raspberry Pis. NIM libp2p was actually created to meet the needs of Nimbus. And yeah, since it uses so few resources, it is an excellent choice for not only embedded devices, also for any kind of server or desktop machine. We also have Waku. Waku is a family of censorship-resistant, private and scalable P2P messaging protocols. It's designed as well to work on everything from browsers to mobile devices. Codex, which is a decentralized storage engine that is built using Azure coding, CK-based remote audits, and also lazy repair. This is to ensure censorship resistance as well as durability of the data. And also Status, which is a Web3 super app that combines messaging, via browser and wallet. It's basically a decentralized WeChat. And it's powered by Waku, among other IFT tech. So yeah, you can see here how NIM libp2p is fundamental in our quest to remove centralized infrastructure, and how we are trying to achieve the original Web3 vision of having a decentralized storage, communication, consensus, and also have an application that allows us to access all these items. Right, so does it look fine? Yeah. So libp2p is pretty much feature complete, as you can see here on this list. There are just few gaps left. Those items that are marked in those items that are marked in yellow are those that are being currently developed, and those that are marked in red, yeah, they still don't exist, but they are planned to be work that's going to be done in the future. Yeah, so how does NIM libp2p compare to other implementations? This is a question that is somewhat hard to answer. We were trying to do so via the usage of the PERF protocol, which is one of the protocols part of the libp2p test plan. However, we weren't able to finish this work before this presentation. But there is an additional data point that we can use to the performance of libp2p. And this is via the comparison of Ethereum 2 clients. So let's take a look at how at how it compares to other implementations. NIM here is line in this graph.
Sorry. Just stay behind the microphone.
Okay. Nimbus is represented by the green line of this graph, and as you can see here, for both metrics, memory usage and CPU, it consistently stays in the lower range. This data here, it comes from an analysis that was done in 2023 by Mega Labs, and it shows how different clients behave on their validation load. And yeah, I want to think that part of the reason why Nimbus performance is so good is because of the usage of libp2p, because it is lightweight by design, so it should help keep the resource consumption low. And on this regard, Megalab says that Nimbus is the client with the lowest CPU and memory requirements across all platforms, as well as the fastest syncing open source client. It is clearly the client better suited to run in low power devices, but it also performs well on powerful servers. An amazing quote. Right. But when people see libp2p, they always end up with a couple of questions, like what is NIM and why we use NIM. I will try to answer both of these questions. So, what is NIM? If you haven't seen it before, think of a programming language that has a Python-like syntax, but with C-level performance. It compiles to C, interoperates with other languages in an extremely easy fashion, and it's very readable, as you can see here. Yeah, having all these characteristics is something that you want when dealing with maintaining systems code, right? And I chose this super dead simple example of it's basically a hello world, so we can see the vibe of NIM. So in this example, you can see that it has a static typing. The syntax is very clear. It has a module system that you can access via the import keyword. The string operations are very intuitive. And also there is an implicit result return, meaning that you don't have to use the return keyword unless you want to. And yeah, if you want to compile this, it is as simple as executing this command that you see here at the bottom. So, too long didn't read. NIM is a language that reads like a script, but compiles to a native binary. For the second question, yeah, this is somewhat harder to answer. It's just not a technical decision. It's also about the values that we have at the IFT, because NIM gives us the flexibility we need and the control to build the kind of systems that we care about. Systems that are minimal, resilient, and optimized for low resource devices. So there are three concepts that we took into account when choosing NIM. The first concept, the ideology, because a lot of our work started because we weren't happy with the current state of existing tools. Waku came on about because Whisper, which was a messaging protocol created by the Ethereum Foundation, that protocol sadly did not go anywhere and also wasn't built for the kind of devices that we care about. Nimbus exists because we needed also something more aligned with our goals, especially for mobile and embedded devices. And by now, Nimbus has actually helped shape Ethereum itself. And libp2p follows the same logic. We are focused on things like privacy, censorship resistant, and a lightweight design. At DIM, give us the space we need to follow our own direction. The second concept, the technology, because NIM produces native dependency-free binaries, which is huge for resource-constrained environments, and it also supports a spec-first workflow. It interrupts very well with other languages like Rust, and it gives us a solid base for developing low-level protocol work. And plus, we are just not passive users. Within the IFT, we actively contribute to the language itself, so we can try to push it into the direction we want. And finally, the history. We started using NIM just to get out from the undergo Ethereum dependency, and since then it's been a surprisingly, well, not surprisingly, it's been a great choice. Because with relatively few developers and not much tooling, we have created a ton of projects like Waku, Nimbus, Status Desktop, Codex, libp2p, NIM libp2p itself, the list just goes on. And yeah, it's a proof that a small development team using NIM can be very productive. So yeah, after this quick introduction, let's move to something a bit more fun. Let's try to implement an echo protocol in libp2p. Echo protocol is an extremely simple protocol. Basically, the client will send a string to the server will take the string and reply it back to the client. And for that, we are going to do a quick demo. Hopefully the demo gods will not be angry with me. Let's see. Wait. Right. Control tab. Right. So yeah, I really don't believe in live coding, hence I'm cheating here. But I'm just going to show quickly which commands we are supposed to execute. Basically, we use Nimble, which is the package manager of NIM. These commands, what they do is basically initialize a new project. We are supposed to edit a Nimble file in which we are going to edit the metadata for the project to specify that we are going to use libp2p, and then we can start editing a file echo.nim where we are going to define the actual protocol. So let's assume that we executed the first 4 steps and we are using VI now because, yeah, we don't use Emacs here. So yeah, full screen. The first step is just to import libp2p. And afterward, we proceed to create our node definition. We call it the switch. In here, we can specify all the characteristics of the node itself. Like, for example, we are going to use Ramos as a muxer, listening on a specific address, use the noise security, and TCP transport. Afterwards, we proceed to import Chronos. Chronos is our own custom asynchronous runtime. And yeah, we need to define a main function which is going to be like the function that will execute our test program, right? In this function, what we are doing is specifying the multi-address on which we are going to be listening to. In this case, both the server and the client are going to be listening to the same multi-address, but it does not matter because as you can see there that the port is 0, meaning that we are going to get a new random port when we instantiate the node. Basically, we start both nodes, keep space empty to do the actual logic, and then we stop the nodes. And then we call this function wait for main just to execute the main function, because main is defined as asynchronous. Right. So what are the steps that we need to define our protocol? First, we need the protocol ID. We call them the codec. So in this case, the protocol ID is going to be echo version 1.0. And then we need to create an object that will represent our protocol, inheriting from LP protocol. Within that object, we define a handler, which will be the function that is going to be executed when we receive a request on our protocol. Yeah, so next step is just to instantiate the protocol and assign it to the actual node. In this case, switch 2 is going to represent the server, and associate need to mount the protocol itself. Right, so how do we make bot nodes be able to communicate to each other? Pretty easy. The client is going to dial the server by specifying the peer ID, the addresses, and over which protocol is the communication going to happen. We define here a simple client function. What the function will do is just write into the stream the stream that we want to pass. In this case, a hello world. And then within our handler, what we do is read from the stream. In this case, I'm using a helper function to convert from bytes to a string. I just echo, I just print what I received, and proceed to reply back by writing over the same stream. And finally, on the client, we read from the stream and print on the screen what the server says. And here I'm doing the actual client call. So yeah, to run this example, it is as simple as executing this command, and we are going to see this live. Okay. Oof, that was really quick. Okay, so basically we can see there at the bottom that the client sent a hello world. The server is indicating that, hey, I received this from the client, I received this hello world, and we'll proceed to reply back to the server. Then the client is going to print the server said hello world. Super simple, as you can see. And also on the previous line is just some debug logs to see the operations that were executed. Like, for example, the node that was started, that we are dialing appeared, that we accepted a connection. The list just goes on. So yeah, coming back to our presentation. Let's see. Yeah, I'm just going to skip this slide. Right. So looking ahead, I'm just going to present some of the initiatives that we are currently working on. Don't be afraid, it's just 3 slides. So yeah, one of the initiatives that we are currently working on is the Mix protocol. And what is Mix about? libp2p protocol by default doesn't do sender anonymity. Like your peer ID and your traffic is exposed out there. You are compromising your privacy that way. And if you care about privacy, which you should obviously, this is a problem. So Mix protocol patches this hole by providing an optional privacy layer that you can use. And it works like this. It splits the messages into a fixed size layer encrypted packets called Sphinx packets. And these packets are routed through a random chain of mixed nodes. Mixed nodes are just libp2p nodes that are run in the Mix protocol. And each one of these nodes is going to add a random delay before sending the message forward. And each node can only know about its immediate neighbors, meaning that they only know who sent the message to them, and they only know who they can send the message to. That means that no one can see the full path, meaning that you cannot link the sender to the recipient. And that way you get a strong anonymity. There are no need to do any change in your protocol definition, but of course you need to change the implementation to determine how you are going to use mix. For example, the experiments that we are doing, we use a mix with gossip sub only for the first hop. And yeah, the link is there in case you want to read the specification. Another initiative that we are working on is Gossip Sub 1.4, and there is a call to action here if you want to scan the QR code, because there is an open PR to the spec repositories, and we would love some comments there. But what is Gossip Sub 1.4 about? Well, it tackles a key deficiency of libp2p, of Gossip Sub. Like large messages take time to be transferred, and that delay creates a window or contention interval. And during this window, peers flood the network with I want messages. And yeah, these are redundant I want messages. And why? Because they don't know that others are already sending the message. They cannot say, I don't want this, until after getting the whole message. And by the time the I don't wants go out, it's too late because message duplication has already happened. Version 1.4 fixed this by introducing two new control messages, the preamble and the I'm receiving. The preamble goes out before any big message, and it signals what is coming. It contains the message ID and the message length. And the I'm receiving, it's very similar. And what it does is that receiving peers are going to send the I'm receiving message to their mesh, indicating that they are currently getting a message. And now, other peers back off sending that message to them. Peers also avoid sending I want for stuff that they are already receiving, and they only allow one active I want per message. And the result is fewer duplicates, less waste of bandwidth, and a smarter network overall. Yeah, and other initiatives that we are currently working on, well, these are based on the list of features that we saw before. We are currently actively developing web transport, Cadenia DHT, and AutoTLS. The others are just planned work for the future. We, from week to week, publish our progress in roadmap.back.dev. So if you are interested to see how things are progressing, you can go to this link here. And yeah, that's pretty much it. Here are some useful links, our website, our X account, also the GitHub repository for libp2p, where you can see examples, documentation, the whole thing. Also, our Discord server, and a QR code in case you want to join and just say hi, ask questions. And yeah, thank you very much.